In this short video, we'll discuss a couple of more basic rules of the derivative. The first rule is product rule. So the product rule says the derivative of a product of the two functions f of x and g of x equals to the derivative of f of x multiplied by g of x plus the derivative of g of x multiplied by f of x. Now let's look at an example. If you want to find the derivative of sine of x multiplied by natural log of x, you have to use the product rules by finding the derivative of sine of x multiplied by natural log of x plus the derivative of natural log of x multiplied by sine of x. Right. In this case, f prime of x is derivative of sine of x, g of x is natural log of x, g prime of x is the derivative of natural log of x, and f of x is sine of x. So then, as we know that the derivative of sine of x is cosine of x multiplied by natural log of x plus the derivative of natural log of x is 1 over x multiplied by sine of x. Combine everything together, we can conclude that the derivative of sine of x times natural log of x equals to cosine of x times natural log of x plus sine of x divided by x. Now the next rule is the quotient rule. The quotient rule says the derivative of a quotient f of x divided by g of x equals to derivative of x of x times g of x minus the derivative of g of x times f of x divided by g of x squared. In this case, g of x has got to be not equals to 0. Let's look at an example. If we want to find the derivative of tangent of x, we first rewrite it as a quotient of sine of x divided by cosine of x. And now we can use the quotient rule to find the derivative of tangent of x. According to the quotient rules, you would take cosine of x times the derivative of sine of x minus sine of x times the derivative of cosine of x divided by cosine squared of x. So the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. Put everything together, you will have cosine of x times cosine of x minus sine of x times negative sine of x divided by cosine squared of x. So you see that minus and minus will give you a plus. So you would have cosine squared plus sine squared, and this is one of the trig identities, will give you 1. So you can simplify the numerator into 1 to get the next result is 1 over cosine squared of x. And we know that 1 over cosine of x is secant of x. So 1 over cosine squared of x is secant squared of x. As a conclusion, the derivative of a tangent x equals to secant squared of x. And we found this derivative using the quotient rule. Let's look at another example. If you have a function, let's say f of x is 2x squared ex plus natural log of x times tangent of x divided by 3 square root of x. At first, you want to see if you can simplify these functions. I don't think that we have any common terms in the numerator and denominator to simplify. So unfortunately, we have to use a rule to find the derivative of these functions. Since this is a quotient, we use a quotient rule. And as a reminder, if you have a quotient, then this is the formula for the quotient rule. Now in this case, I use g of x and h of x as the functions of the top and the function of the bottom, just to differentiate with f of x. So the top functions is g of x. The bottom functions is h of x. Now, if you use a formula, you need to find g prime of x and h prime of x. So we start with g prime of x is the derivative of the top functions. And as you can see, this is a sum of two functions, so we can use the sum rule, and you have a constant 2 multiplied by x squared e to x, so you're going to use a constant rule and the sum rule, right? And you split this derivative into two different derivatives, and each of the derivatives is a derivative of a product of the two functions, so you have to use a product rule. So as a conclusion, the derivative of g of x, g prime of x, is the functions in the blue. And here you can see that the derivative of x squared e to the x is 2x e to the x plus x squared e to the x. The derivative of natural log of x times tangent of x is 1 over x times tangent of x plus natural log of x times secant square of x. The next thing is we want to find the derivative of h prime of x. First, we want to move the constant out and convert square root of x to 1/2 so that you can use a power rule to find this derivative. Right? We move 1/2 down and we take 1 from the power to get 3 over 2 times x to the negative 1/2, or 3 over 2 times x to 1/2. You can convert x to 1/2 back to the square root of x to get 3 over 2 times square root of x as the derivative of h of x. Now we have g of x, we have h of x, we have g prime of x, we have h prime of x. We're going to put all the information here into the quotient rule formula, right? So we have g prime of x, h of x, minus h prime of x times g of x, divided by g squared of x. And keep in mind, the denominator, you have 3 over 2 square root of x squared. You can simplify it using the power rule, one of the power rules. So it's going to be equals to 9 over 4x. So as a conclusion, the derivative f prime of x equals to this functions. Looks complicated, but if you know which rule to use, you can break the problem down into smaller pieces, tackle each of the pieces, and put all the pieces together. This looks like a puzzle for me. Again, if you need to use a quotient rule, identify the top functions, the bottom functions, find the derivative of the top functions, derivative of the bottom functions, and put everything into the quotient rule formula to get to your derivative. So using the product rules and the quotient rules, we can find the derivative of 4 more trig functions. As we know that, we learned before that derivative of sine is cosine, derivative of cosine is negative sines. And again, product rule and quotient rules will help you find the derivative of tangent x, which is secant square of x. Derivative of secant of x is secant x times tangent x. Derivative of cotangent of x is negative cosecant square of x. And the derivative of cosecant of x equals to negative cosecant x times cotangent x.